Hello and Assalamualaikum. Today I'm going to doing a demo about my FYP project. So my project introduction. So the title from my project introduction is Impact of Fault Level on Ground Grid using ETAP. Project is fully based on simulation by analyzing the impact of a level of 40 kA, 44 kA and 50 kA on ground grid. So next is tool description and why it is suitable. So the main tool that I have been using is Electrical Transient Analyzer Program, ETAP. So why it is suitable? So first is complying with IEEE standard. ETAP ensures IEEE standard compliance for reliable ground grid analysis. Second is accurate ground grid modeling. ETAP simulates precise and detailed analysis of ground grid behavior during faults. So and lastly is visual and tabulated outputs. So ETAP displays voltage profiles or warning indicator clearly to identify unsafe fault conditions. Cool. Today I'm going to do the demo presentation for my FYP. So first you need to click the ground grid and you need to paste on the screen. After that, you double click it. So next is you choose the edit mode and you pick the IEEE rectangular shape and paste it on here. So you need to double click here and you need to edit all of these parameters using the parameter for my FIP for conductor and the roads as well. So next is you need to edit the soil resistivity. So for my FIP is the surface material, you will choose the gravel, and top and a lower layer we choose the moist soil. So you need to key in the data using my parameter. So you click OK. So after that, you click on the ground grid study. To simulate all of this, first you need to edit, click on the study case, key in all the parameter. For example, this fault current is indicate my fault level. So for example, let me choose 40 kA and click OK, and then run the simulation. So it will show the simulation for touch and step value and GPR value and grid resistor value. So let me do for example for 50 kA. You click OK and let's run it again. And then it will show the value for 50 kA. So the value is changing and it indicates the warning signs, which is the short time temperature rise of ground conductor or exceed the limit. So for 44 kA, do the same as well. So next is the case simulation result. So this three, as you can see, is the three main findings for my FYP. So on the left one, which is the result for 40 kA, which indicate the value of touch and step, GPR, and grid resistance. So in the middle one is the 44 kA result, and the right one is the 50 kA result, and has a warning sign: the short time temperature rise of ground conductor, and or exceed the limits. That is the theory validation. So how I'm validate my simulation. So to validate the simulation result, they will compare against the manual theoretical calculations. So these are the validation that I use, which is the tolerable touch voltage, the formula for tolerable step voltage, the formula for ground grid resistance, the formula for ground potential rise, the formula for calculated mesh voltage, and lastly calculated step voltage. This theory calculation will compare to the simulation to validate. So what is my limitation and constraint for my FYP? So for the first one is modeling assumptions and simplifications. So ETAP uses simplified models that may not capture real site conditions. So the second one is validation challenges. ETAP result should be validated against manual IEEE standard calculation to ensure design safety. So and the last one is accuracy limitations. So simulation accuracy highly depends on the input data like soil resistivity and fault current. Okay, so for the conclusion, it has supported this project by simulating fault levels, analyze such as step voltage, GPR, and grid resistance, ensuring safety and complying with IEEE standards. So this project highlighted ETAP's strengths in modeling and standards compliance, but its results depend on input accuracy and modeling assumptions. So manual validation is necessary for reliability. Thank you.